Hello everyone, this Science of Sport video is for BTEC Sport and Exercise Sciences, Unit 2 Functional Anatomy. We're looking at Learning Aim C, which is all about the respiratory system, and in particular we're looking at C2 functions of the respiratory system, and there are 3 functions. This is part 3, so looking at the 3rd function, and this particular video will look at the lung volumes you need to know for exam questions. So the specification actually only requires you to know 3 lung volumes: tidal volume, vital capacity and residual volume. And we'll go through those. I might mention a couple of others which are related, but these are the 3 that the specification specifically focuses on. So the first thing we need to know is how we can measure lung volumes in the first place. And we measure lung volumes by a spirometer. So some of you may have had a go on these at school, where basically there's a mouthpiece. It depends on how technological it is. There are different versions of it, but basically there's a mouthpiece which is connected to some kind of recording device. When you breathe in, the line on the recording device goes up. When you breathe out, it goes down. And the little squiggles here, the shallow ups and downs, are shallow resting breathing. If you take a deep breath in, the line goes up more. So this vertical line up here is a deepest breath in somebody could do. And breathes out, shallow, shallow, breathe in deep, breathe out, and breathe out as much as they can. So they're really expelling all their air here, and then back to normal shallow breathing. So you need to know that lung volumes are measured by a spirometer. This is the machine that measures lung volumes. So then, just to try to show you the difference between what we would call a lung volume and a lung capacity, lung volumes are directly measured by the spirometer I just showed you. So we can actually measure certain volumes of air that we have in our lungs. Others are determined indirectly from our spirometer data, so we can't directly measure them. The ones that we can measure are called residual volume, tidal volume, both of those which we need to know, expiratory reserve volume and inspiratory reserve volume. They're not listed on your specification, but actually they're quite easy to understand, so I might well be mentioning those in a minute. In terms of the lung capacities, the one that you need to know is called vital capacity, and the others aren't required. So again, lung volumes are directly measured and capacities are estimated or calculated from lung volumes. So before we look too specifically at the volumes, let's get a sort of a sensible overview of why we might care about lung volumes, how much air we move in and out of our body. You'll need to understand this term ventilation. So ventilation is basically defined as the volume of air you breathe per minute. It used to be called, and sometimes you'll see in textbooks it being called minute volume, which actually makes sense. It's the volume of air, not oxygen, the volume of air breathed per minute. Now at rest, we might breathe a relatively small amount of air per minute because our muscles are not necessarily needing a great deal of oxygen, and we're not producing a lot of carbon dioxide. We're not having to move air in and out of our body too frantically. During exercise, it also makes sense then that we breathe deeper, we breathe faster, and we would move more air in and out of our body per minute, i.e. ventilation would go up. So I just wanted to sort of set the scene. We're going to talk about certain volumes, and it's relevant because at rest we need a certain amount of air moved in and out of our body per minute. When we exercise, we need a greater, an increased amount of air moved in and out of our body per minute. Ventilation is measured in litres per minute, so litres of air per minute. It's not litres of oxygen, it's litres of air per minute. We calculate ventilation by knowing what a tidal volume value is, and I'll talk about that in a moment, and how many breaths we take per minute. Tidal volume is measured in millilitres, and breathing rate is in breaths per minute. How many times you breathe per minute? Typically, we breathe at rest about 12 times a minute. Typically at rest, tidal volume is about 500 millilitres or half a litre, 500 millilitres a minute, which means that at rest we would ventilate about 6 litres of air per minute. So, logically, as I said, if we are exercising, firstly, we breathe faster, so our breathing rate goes up. Secondly, we breathe deeper, so the amount of air we breathe per breath goes up. So if both or one or both of these factors goes up, ventilation will go up. And obviously in exercise, we ventilate more than we do at rest. Okay, I'm going to leave that there. Well, let's look more specifically at some of the volumes and capacities that you need to know. So we know already that a spirometer measures lung volumes. This actually is a spirometer trace. So the squiggly line, as I've said already, represents the in-breath and the out-breath. The in-breath, the out-breath, the in-breath, the out-breath. Big in-breath, big out-breath, back to normal in-breath, out-breath. Okay, so this is a spirometer trace. The first lung volume that you need to be able to identify on a spirometer trace, because you might be given one of these to identify elements of, is tidal volume. Now, if you think about the sea and you think about tides, they go in and they go out. They go in, they go out a couple of times a day. So it makes sense that this in-breath, out-breath is called tidal volume. Basically, how we use this spirometer trace is the height of the tidal volume squiggle here, there between that and that, the height of that is the amount of volume that is tidal volume. So tidal volume is the volume of air breathed in per breath. The volume of air that we move into our body per breath. So from here we inhale and we breathe in that amount of air. So this is a relatively normal resting tidal volume. This is your this sort of low, shallow breathing here is your 500 millilitres. This breath here is a deep breath in. It still represents tidal volume. If there were multiple big breaths there, it would still be called tidal volume, but the size of the tidal volume would be greater. So always the difference between the sort of bottom, the trough, and the peak of this little squiggly line is called tidal volume. Tidal volume varies depending on how deeply you're breathing. It's basically how deep are you breathing. And at rest, we breathe shallowly and we move 500 millilitres of air per breath. So I'm just going to jump to the next slide here. Tidal volume, this is one that you definitely need to know. Tidal volume is the amount of air moved in and out of the lungs during quiet breathing. That means at rest, and approximately 500 millilitres. And it would be the squiggles here. The little squiggles here show breathing at rest. Let me go back. So, shallow breathing here, small peaks and troughs. In breath, out breath, in breath, out breath, in breath, out breath. If I were to take a deep breath in, a deeper breath in, and inhale a greater volume of air in that breath, I go beyond my normal tidal volume and I take in extra air. I inspire extra volume. Now this darkened, almost browny, sort of pinky looking area up here, this area above our normal resting tidal volume area is called the IRV, our inspiratory reserve volume. Now this basically represents the extra volume of air that I could take in if I needed to. It's got a limit, of course, because if I take in any more than that, my lungs will explode. They don't have the capacity to take in more than that. So I could take in from this that much more volume, and then I'd be at my maximum inspiration. And then let's say I breathed that out and I'm back down to normal. So this is my inspiratory reserve volume between 3,000 and 6,000 millilitres. So 3,000 in total millilitres in this particular example. Shallow breathing is normal breathing, 500 mils in and out, but I could take a deeper breath in, use some of my reserve volume, and move more air into my body if I needed to. Now, obviously, this peak here is showing the extreme I could breathe in, the deepest breath in I could. I could take sort of moderate deep breaths. So I could, if you follow my cursor, I could breathe in this much and out this much. And this, if I'm exercising moderately, I might only breathe that much more in. Still more than normal, but it's not maximum. This represents my maximum in-breath, and I use up all of my reserve volume. But I might breathe moderately and just use part of my reserve volume. So this line just shows how much air am I taking in on my in-breath. This is normal. This is extra. This is using reserve volume that I'm, to move more air into my body. The same principle applies to this blue color down here. So breathing normally, I expel the air 500 milliliters. I breathe in 500 milliliters, I expel 500 milliliters. You know that you can blow lots more air out, if you go, you can expel more air than normal. And you can, not quite, but you can do your best to empty your lungs. You don't fully empty your lungs. We'll talk about that in a moment. So if I breathe out extra, this is how much extra I can breathe out. And this is the point where I've blown out as much as I possibly could and I can't blow out anymore. That's my expiratory reserve volume, the extra volume of air that I could blow out if I tried my hardest. So breathing my deepest, breathing in my deepest, breathing out my deepest, for want of a better word. Okay, inspiratory reserve volume, the extra that you can breathe in. Expiratory reserve volume, the extra that I could breathe out if I tried. These two are not on your spec, but when it comes to exercise, I think it makes sense to understand. Breathing in normally, breathing deeper, breathing out deeper. We do that when we exercise. And obviously, you'll know about breathing mechanics. Exercise breathing mechanics is using extra accessory muscles to increase the volume in your lung of your thoracic cavity even more, to move even more air in. That would be shown on this spirometer trace by this line going up. And we breathe out more frantically. We have muscles, our internal intercostals and our accessory muscles, force our chest cavity in to force air out. That would be the downward movement. So I just wanted to talk about those two because it makes sense. So again, let me go to the next slide. This is just a little bit of detail about those two volumes, but please be mindful that your spec doesn't require you to talk about them necessarily unless you've got an opportunity to show off. It does need you to understand and be able to describe and explain what tidal volume is. Now, the other two things that you need to know for the specification are, where is it here? This one here? Oh, sorry, let me do this one first. Residual volume. So I've talked about expiratory reserve volume, blowing out as much as you can to expel all the air you possibly can in your lungs. But even if you try your hardest, you will not expel all your air because there's just about over a litre of air there that you cannot expel from your lungs, and it's essential that you can't expel it. If you did completely empty your lungs, your lung tissue would collapse. Your lungs would collapse. They would be totally deflated. Obviously, that's not a good thing. So this residual volume represents the amount of air that we cannot expel from our lungs, and it is there protectively to stop our lungs collapsing. And there has been an exam question on this, by the way. So residual volume, let me jump to this slide. Residual volume, the amount of air remaining in the lungs after maximum exhalation. So we've breathed out, where can we go? Breathed out as much as we possibly can, and we've got somewhere between 1 and 1.2 litres left in there that we can't expel. And it's there for a protective reason to stop our lungs collapsing. That's the second thing that's on your specification. The final thing that's on your specification is this grey one here, and it's called the vital capacity. So we can calculate vital capacity. We can use the volumes that we can measure to calculate vital capacity. Residual volume is calculated actually based on your height the taller you are, the bigger your residual volume. Anyway, vital capacity basically is it's your total inspiration down to your total expiration and does not include residual volume. So if you took the deepest breath in you possibly could and then breathed out the deepest breath you possibly could, so you breathe out in the most and then expel it all, that is basically your lung capacity. That's the amount of air that your lungs can hold with the exception of residual volume. So vital capacity is described as a maximal inhalation followed by a maximal exhalation, and that is basically measured. You can see from the top to the bottom there is the same as from the top to the bottom there. And you can see it's round about 5 litres or so. So vital capacity is the maximum amount of air moved in and out of one of the lungs in one cycle. The lungs in one cycle. Maximal inhalation, it's the maximum, that's the really key word. The maximal amount of air that can be moved in and out in this cycle. Breathing in them as much as you can, breathing out as much as you can, down to the residual volume, but not including it. So if you look at this, vital capacity is your your inspiratory reserve volume, the yellowy stuff, in this one the tidal volume, your purpley stuff, and in this one the bluish volume, the expiratory reserve volume. So it's those three factors, not residual volume. So here's a little summary slide to give you a sense of the three red terms that you do need to know based on your specification. What is tidal volume? What is residual volume? What is vital capacity? One exam question did ask you, what is residual volume? And you had to gain, I think, a couple of marks from it. You had to talk about why it's so essential as well as what it is. So it is the volume of air that we cannot expel. Why can't we expel it? It's because it's a protective thing. It's there to stop lungs collapsing. So it's really important you understand why we don't expel it. But you might need to give typical values. I've always taught residual volume is about 1 litre, but you'll find different little pieces of resource have different values. So it's approximately 1 litre. Tidal volume is about half a litre at rest, and vital capacity is about 5 litres. The other volumes that I talked about were inspiratory reserve volume, the extra that you can breathe in, expiratory reserve volume, the extra you can breathe out. And actually I didn't really mention total lung capacity, but it's basically from the bottom to the top. It's vital capacity plus residual volume. So it's your whole lung capacity. Here's an exam question that I found so far. So it gives you a spirometer trace. It asks you to identify what is this and what is this. Hopefully you'd recognise that being tidal volume and that being vital capacity. So you got 2 marks for just saying that. And then it says describe the function of residual volume. So here it is. It tells you where residual volume is, but it wants you to say what's its job. And look, residual volume prevents the lungs from collapsing as it is the volume of air left after maximum expiration. Easy marks.